A nuclear inspection robot. Hello and welcome to our YouTube channel, Fun Tech and New Ideas. Today, we are going to reveal the latest development of a nuclear inspection robot. So, without further ado, let's get started. Lyra, a robot, was employed to check a vent duct in Downey's decommissioned nuclear labs to map radioactive elements. Lyra crossed 140 meters of duct from a sole entry point, providing managers with comprehensive radiological characterization data that can now be utilized to aid planned safe and efficient laboratory deactivation. Obtaining this level of detail used to be difficult, and even when it was possible, it would necessitate additional airline suit entrances into polluted regions, increasing cost and risk. Humans can't get into this area right now because of how big the conduit is and how dangerous the radiation is. This installation has shown that mobile robots can be used to speed up the decommissioning of old nuclear sites in the UK, while also reducing the risk to people, costs, and even the amount of new low-level waste made during decommissioning. Lyra's design. Lyra was developed as a low-cost robot with 5 radiation sensors, a laser scanner for tracking, 2 cameras, lighting, and a manipulator arm for swabbing radioactive pollution off the duct's floor or wall. Scientists from the University of Manchester made Lyra as part of the Robotics and Artificial Intelligence for Nuclear, or RAIN hub, with help from the technical and operations experts at Downey Site Remediation Limited, or DSRL. Lyra was outfitted with tracks and given a reasonably high ground clearance in order to clear the significant amounts of rubble that lay in the duct. The radiation sensing kit was intended to measure beta, gamma, X-ray, and neutron radiation and was equipped with a 5DOF manipulator to collect swabs for further radiological examination at the site labs. Cameras were fitted to the front of Lyra as well as the manipulator's end. The camera linked to the manipulator allows for a thorough examination of any points of interest discovered throughout the survey. Lyra is driven by a joystick and controlled by a flexible manipulator arm that moves in the same way as the robot's arm. Function with the LiDAR radar and live camera footage allowed the creation of a 3D time-stamped video with the radiation observations as measured overlaid onto the video, allowing any point of interest or high radiation measurement to be pinpointed at any specified spot within the duct. The operation. Lyra was installed in collaboration with the DSRL operations unit. The inserted frame includes additional cameras, lights, and backup networking. DSRL is tremendously grateful to the crew from the University of Manchester. Their contributions, combined with that of FIS 360 Managing Director Frank Allison, have clearly illustrated the significant advantages that can be realized through teamwork with the supply chain, said DSRL Project Manager Jason Simpson after the successful implementation of Lyra. Now that the duct characterization study is finished, we have a thorough image of the duct that will allow us to make educated decisions about how to decommission it in the future. While it is acknowledged that the rewards for succeeding differed for all parties, the enthusiasm and dedication shown by Frank Allison, Barry, and the rest of the Manchester team guaranteed our objectives would eventually culminate in the fruitful implementation and data capture witnessed via Lyra. We intended to illustrate that the robot could be utilized successfully in active places. RAIN Hub Director Barry Lennox stated, "We incorporated fail-safe measures such as a distant reboot switch and a winch to allow us to physically remove the robot if it became caught in the duct debris." The survey proved Lyra's dependability in active locations. FIS 360, a technology and innovation transfer firm, assisted with the rollout. The development and implementation of Lyra underlines the advantages that robotics technology provides the nuclear sector and the relevance of academia, end users, and enterprises in the distribution chain collaborating together, stated Frank Allison, their managing director. Only through joint work such as this can complicated problems such as inspecting the downread duct be solved. The research team gratefully acknowledges the services of the Lyra robot, which were made accessible for this project under the NNUF Hot Robotics program. The Lyra robot is one illustration of a mobile robotic platform developed for hazardous environmental assessment, and it is available on the market from ICE9 Limited. Lyra, an illustration. The Lyra robot is a prototype of a mobile robotic platform made for assessing dangerous environments, and ICE9 Limited sells it to the public. The research team is thankful for the help of the Lyra robot, which was easy to use for this project because it was part of the NNUF Hot Robotics department. I hope you like this video. Please like and subscribe to our channel. Thank you.